This is one last example problem. This is example problem 11. These are all just different two-dimensional vector problems, practicing vector fundamentals, vector principles, learning how to write scalar equations, learning how to solve the vectors using graphical methods, law of sines, law of cosines. So this is one last problem. So basically, this problem, I have two different vectors, an A vector and a B vector. A is 70 kilonewtons at 40 degrees below the positive x-axis. And this vector, the B vector, is 100 kilonewtons at 20 degrees above the negative x-axis. And so I want to determine an F vector and its theta such that the sum of A plus B plus F is equal to 0. In other words, we're basically requiring equilibrium of point 0. And so which basically what means what we're going to do is we're going to sum forces in the x direction is equal to 0 and sum forces in the y direction is equal to 0. And that's what we're going to do over and over and over again here in statics. So what we're going to do is we're going to write these x and y equations. In the horizontal direction, I have f cosine theta plus 70 cosine 40 minus 100 cosine 20 is equal to 0. In the y direction, I have f sine theta minus 70 sine 40 plus 100 sine 20 is equal to 0. If you simplify these equations, I get equation 1 and equation 2. And so I have this combined term of f cosine theta and a combined term of f sine theta. If I divide equation 2 by equation 1, my f's cancel, I'm left with tangent of theta is equal to 10.79 divided by 40.35. So my theta is 15 degrees. And my f sine 15 is equal to 10.79. And I can solve for f, which is 41.8 kilonewtons at 15 degrees. So let's think about this. And so I basically have f plus a plus b is equal to 0. And so this a plus b must equal minus f, so that f plus minus f is equal to 0. And so if you think about a plus b, I basically have b plus a, and that gives you this guy, which is the same length as f and acts the opposite direction. And so this is my minus f. To put that another way, this guy is the resultant of a plus b. And so this guy is equal to a plus b. For this point 0 to be in equilibrium, I need a support reaction or I need some other force that exerts a force that's exactly opposite of the resultant here, so that the resultant plus this applied force F cancel one another out. I end up with equilibrium. And so in a large scale scheme of things, as we go on in this class, we're going to do resultant problems here early on, which is the resultant of a system of forces. But then we're going to find support reactions to keep this body in equilibrium. But in effect, the support reactions have to develop the opposite of the resultant for the forces to sum to 0, for my body to be in equilibrium. And so These are all pieces of what we're going to be doing and figuring out in statics. But these 11 problems are all 2D vector problems that to introduce you into 2D vectors, the different operations, the different concepts that you need to know, how to use your calculator. Learn these well, and if you can figure this out, you're well on your way to becoming a great statics student.